Okay, so let's consider additional rules of differentiation. One rule is called the constant multiple rule, and that is, what if we differentiate a constant times a function? So we ask, what's the derivative of a constant c times the function f of x? And the rule says you can simply pull out the constant from the derivative. So all you have is the derivative of c times f of x is simply c times the derivative of f of x. And you can write this again more concisely as f prime of x. So all you have is c times f prime of x. And that is called the constant multiple rule, right? C is a constant, and it is a multiple of the function. So the derivative of a constant times a function is just a constant times the derivative of the function. Let's look at some examples of this with the power rule and then with the sum and difference rule. So what if we asked for the derivative of 2x to the 9? Well, here the constant multiple is 2. So the rule says the constant multiple just stays there, so it's 2, times the derivative of the function. So the derivative of x to the 9. And with the power rule, this is 9x to the 8. And now we can just rewrite 2 times 9 as 18. So all we have is 18x to the 8. And that is the constant multiple rule. If we have, say, the derivative with respect to x of pi over x cubed, well, here we have to manipulate, right? We have to use the power rule, so bring the x up, and this becomes the derivative of pi x to the negative 3. And now we're good to go. Pi is a constant multiple, right? It's about 3.14159 times x to the negative 3, so pi stays there, times the derivative of x to the negative 3. Once again, we have x to a fixed power, we can use the power rule. Times, we bring the power down, negative 3, x to the negative 3, negative 1, negative 4. And we can simplify here in two ways. We can write this as negative 3 pi. And if we want, we can send the x down to get a positive power of 4. And that is the constant multiple rule. Let's now include this with our power rule, our sum and difference rule, and the constant rule in one example. What if we asked for the derivative of the following function? So d over dx of, let's go with 2/3 x to the 6 minus 5x plus 3 over x minus 17. So now we ask for the derivative of a sum and difference of 4 functions. Before we move on, we have to rewrite 3 over x as 3 times a power of x. So we have the derivative of 2/3 times x to the 6 minus 5x plus 3 times 1 over x is x to the negative 1 minus 17. And now we can apply all the rules together. Sum difference rule, constant rule, power rule, constant multiple rule. So the first term, derivative of 2/3 times x to the 6. 2/3 is a constant multiple, so it just stays 2/3, times the derivative of x to the 6. We now use the power rule. We bring the power down, x to the 6 minus 1 is 5, and that's the derivative of the first function, minus 5x. Well, 5 is a constant multiple of x, so it stays 5. And the derivative of x is just 1, right? This is, if you think of it, you can think of it in two ways. If you think of the power rule, d over dx of x is x to the 1. Well, you bring the power down, so you bring 1 down times x to the 1 minus 1 but that's just 1 times x to the 0, and x to the 0 is equal to 1. So all you have is 1 times 1, which is 1. Or you can think of it even in simpler terms. Y equals x is the line y equals x, so it has a slope of 1. So the derivative of x is just 1. That takes care of the second term, plus 3 here is a constant multiple, so 3 times the function, so 3 stays there, times the derivative of x to the negative 1. Once again, we use the power rule. Times, we bring the power down, negative 1, x to the negative 1, negative 2. And finally, minus the derivative of 17. 17 is a constant, so it's just a horizontal line. The slope is 0, hence the derivative is 0. Let's simplify a little bit, right? We have 2 times 6 over 3, but 6 over 3 is just 2. So what we have is going to be 4x to the 5 minus 5 minus 3. And you could leave 3x to the negative 2, or if you prefer to have a positive power, send the x down, and the negative power of 2 becomes a positive power of 2. And now you have the derivative of this function. So you see, you can combine in one problem the constant rule, the sum difference rule, the power rule, and the constant multiple rule. In our next video, we'll look at the product rule. So what if we have the derivative of a product of two functions? And also the quotient rule. What if we have the derivative of a quotient, of a division of two functions?